Okay, hello everybody and welcome. So we are going to be talking about heat and phase changes today. In our packet, we're going to be focusing on page 12, talking about calculating heat of vaporization and heat of fusion. So when we're calculating these two numbers, we have to look at how much heat energy we get from phase changes. And here's the thing, if you remember from the graph that we had from a couple of days ago, whenever phase changes occurred, the temperature didn't change. It stayed flat. It stayed a plateau. And so we're not going to be using the Q equals MCAT formula from yesterday because there is no change in temperature. So this time we have to use a different formula. We still have Q representing the total amount of heat. We still have M representing mass, but instead of C delta T, we're going to have heat of fusion or vaporization here, represented by a capital H. Now, which one of the capital H's you use depends on what phase change is happening, but also what substance you're looking at. So for us, we're going to be looking at the heat of fusion of water. So on page 2, or heat of fusion and heat of vaporization of water. So on page 2 of your packet, up here, underneath where it says constants, you have the heat of vaporization and heat of fusion listed here. The values for those are listed. And so we're going to be using those numbers for our heat. But depending on which phase change you're going through, we'll either use that as a positive number or a negative number. And something else to keep in mind, heat of fusion is only going to be used for melting and freezing, whereas heat of vaporization is going to be used for vaporization and condensation. But here's the other part of it. For melting, the heat of fusion is going to be a positive value, so you can use the number as is. But for freezing, the number is going to be negative because we are removing heat to freeze that substance. So it'll still be the same number, it's just going to be used as a negative. And then same sort of deal for heat of vaporization. When you're vaporizing something, it's going to be a positive number, so you're using the number as is. But when you are condensing that substance, you are cooling it down, you're removing heat, and so we gotta make heat of vaporization a negative number. So let's do this in a practice. So how much heat is needed to melt 56.2 grams of ice at 0 degrees Celsius? The 0 degrees Celsius just lets us know, yes, this is ice. The melting point or freezing point for ice is still going to be 0. That still hasn't changed. But since we're wanting to calculate heat, not heat of vaporization, we're given mass, and we know that this is melting ice, so we're going to be using heat of fusion. So our formula looks like this. Q equals mH subscript F. So heat equals mass times heat of fusion. And so our mass given to us was 56.2 grams, and the heat of fusion is 334 joules per gram. And something to note here is the units for grams are going to cancel, leaving us with joules. So our answer for this problem with the correct number of sig figs is 18,800 joules. So we're not including the 0 degrees Celsius because that was just letting us know that yes, a phase change is happening at that particular temperature. The number that we actually used is 56.2 grams, which has 3 sig figs. So our answer needs to have 3 sig figs as well. And another thing to note is just like when we were calculating heat yesterday, when the heat is a positive number, that means it's going to go through an endothermic phase change. It's going to be absorbing that heat. Now, for example, problem number 2, In this case, we're wanting to know how much heat is released when 120 grams of steam condenses. So we're dealing with gas at this point, and it's changing into liquid. So we're condensing. So we're going to be using heat of vaporization, but since we're going in the opposite direction in terms of heat energy, we're going to make that a negative number. So negative heat of vaporization. So for this formula, it's Q equals M times H, but this time we're using heat of vaporization. So that's what that little V stands for. So taking our 120 grams and the heat of vaporization for steam is negative 2,260 joules per gram. Gram still cancels, leaving us with joules. And then when we multiply these two numbers together, we get 270,000 joules, negative 270,000 joules. And that means that since the negative is there, heat is being released, also called being exothermic. So we'll go into the ideas of endothermic and exothermic later on, but something to keep in mind is that for endothermic processes, they are absorbing heat energy. And usually the heat will be a positive number. For exothermic phase change, for exothermic anything, it is going to be releasing heat. And that's why it's a negative number, because the negative just means you're releasing it. It's going to be exothermic. A quick way I remember the difference between exo and endo is exothermic sounds like exit. So the heat is exiting your system, and so it's going to be a negative number because it is leaving. On the other hand, for endothermic, the beginning of the word sounds a lot like the word enter. So the heat is entering the system, and so it is being absorbed. And that results in a positive heat. All right, so that is it for our notes. What we're going to continue doing for this asynchronous class period is we're going to work on some calculations. So there is an assignment posted in Google Classroom called Calculating Heat, and that has to do with Q equals MCAT calculations, which we covered yesterday. The other assignment is about the notes that we just covered today, and that's going to be Q equals MH. And for those, it's going to be the problems from page 13 and 14 of the packet, all about heat of vaporization, heat of fusion. So make sure to use this time wisely, work on those calculations. Again, it's page 11 for calculating heat, Q equals MCAT, and page 13 and 14 for Q equals MH. They both have Google Forms for them, and they are labeled very clearly. So please make sure to use your time wisely, and I believe I'll have them listed as due on Monday. So then that way, if you have any questions when we come back on Monday, you can ask. So I hope that y'all have a great rest of your day and a wonderful weekend. See you later. Bye.